Okay, so today we're going to talk about section 1.4. The method of least squares. Okay. So the method of least squared is one way that we try to make sense of fitting data point. So the problem that the method of least squares attempts to solve is given data points like x1, y1, x2, y2, xn, yn. So if we have n data points, you can think about these as anything you want. Maybe you could think about x1 as Major League Baseball team's wins in a given season, and y1 as that same team's home runs in a season. And you want to see, is there a relationship, or what's the relationship between team wins and team home runs, right? You expect there to be some sort of relationship to those, right? And so what we want to do is, given those data points, we want to find the straight line that best fits these points. So as I said, an example we could think of would be xi would be the ith team's wins, and yi might be the ith team's home runs. So if we were going to look at these, of course, everything's in the first quadrant, right? For this example, wins and home runs are both going to be positive, no matter how crappy a team the Cubs field. They will not get negative wins, right? They're going to at least, well, non-negative. We shouldn't say positive, right? At least non-negative is what we're looking at here. Okay, so we've got on this axis, we got wins, and on this axis, home runs. And say we have a bunch of data points. Now we look at those data points, and it seems like the more wins you have, the more home runs you have generally, right? The teams that have not very many wins are lower on the home run rating, and the teams that have more wins are higher on the home run statistic. So stands to reason then that maybe there's some sort of relationship between those, and maybe we want to figure out and model what that relationship was, and that would lead us to say, okay, well, what is the straight line that fits these best? Is it this blue line? Is it this red line? Is it this green line? Right, which of those lines is the best one? So it's clear we have to figure out what we mean by the best line that fits those points. We have to have some way of deciding which one of the best is. And one way to determine this is the method of least squares, which is what this section is about. Here's what the method of least squares does. If you imagine a line, and you imagine some data points not on the line, so those are our data points, and the line is the supposed line that best fits it. What we're going to do, what we're minimizing, is we're minimizing the length of these lines here, from the points to the line there. We'll call this E1, E2, and E3. Those are three lengths which measures the horizontal distance between those points in the line. And what the method of least squares does finds the y equals mx plus b with the smallest value of the sum of the squares of all of those distances. Now, my picture only has 3, but I write up to n because in general I might have n data points. Okay, so the method of least squares finds the line y equals mx plus b that gives the smallest value to the squares of those number possible. We're going to learn how to find it by calculation. There's a special formula and it's extremely ugly. But then we'll visit some ways that we can do it with our calculator or with our computer that will allow us to calculate it. And this might happen a fair amount of times in this course. We're going to introduce a complicated mathematical algorithm, and it's going to be hard to use. It's going to take a lot of time. But then if we just go to a computer and type it in instantaneously, we'll get the answer that would have taken us a long time, right? So then we might say, well, why are we even learning about this thing, right? Well, if you're going to use these algorithms in important things like, say, business, which is a good proportion of your majors, I guess if you assume business is important, and I guess if you wouldn't, you probably wouldn't major in it if you didn't think it was important. If you were going to be using one of these algorithms in business, you have to be knowing when something is going wrong. And if you don't know what's inside the box, it's really impossible to tell what's going wrong when you get a strange answer. So it's important to know what goes on in these algorithms. Okay? So that was a long preamble because I'm going to write something now which is not going to be fun to write down, and it's going to be ugly, and you're not going to want to use it because you know that you can just go to a computer and just pop it right away, but we need to show how this works so you can understand when something goes wrong, you can go back and say, okay, what's going on here? Okay, so if we have data points x, y, and there are n of them, we have the following definitions. Sum sign, the big sigma, x is going to be the sum of the x coordinates of your data. Okay, so the sum x is going to stand for the sum of the x coordinates of your data. Sum x squared is going to stand for the sum of the squares of the x coordinates. Sum y will, of course, stand for the sum of the y coordinates. And sum xy will stand for the sum of the products of the data points. So you take each data point's x coordinate times each data point's y coordinate. And we'll do an example with one of these before too long. And n is, of course, the number of data points. Okay, so now I'm about to write down the formula for the slope and the intercept of the line of least squares. Okay, it involves these quantities. M is equal to n times the sum xy minus the sum x times the sum y, divided by n times the sum of the x squareds minus the sum of the x's squared. So that's the formula for the slope of the least squares line. And we'll do an example to see how this works. Don't worry. Just give it a minute there. I'll give you a minute to write that down, or a few moments. Okay, so that gives you the slope of the least squares line. And then the intercept, b, is simply given by the sum of y minus m times the sum of x divided by capital N. So you have to figure out the slope before you figure out the intercept, because as you see, the slope is a term in the formula for the intercept. So you have to do the slope first and then the intercept. Okay, now what we're going to do is, I see you're still writing, and that's fine. I'll tell you what we're going to do. We are going to take a simple example with 3 data points and show how to calculate all of these things and how it works. Then I'm going to show you ways that you can get your technology to do this work for you. Okay? Any questions before we start this example? All right. So my example is going to be 3 data points. They're going to be 1, 6, 4, 5, and 6, 14. So I'm going to make a table. X, Y, the labels of the columns of the table are going to be X, Y, XY to X times Y, and X squared. So the data points are 1, 6, 4, 5, and 6, 14. And I'll give you a second to copy down that table. Okay, over here, this X times Y, I want to put X times Y for this row. 1 times 6 is 6. So the 6 goes in that entry there. Now for the X squared column, I want to square my X coordinate. My X coordinate is 1. 1 squared is 1. The next row, X times Y, 4 times 5 is 20. So X times Y is 20. Now I want to take X squared. X is 4, so X squared is 16. So 16 goes there. In the next row, I take 6 times 14. Well, 6 times 7 is 42. Double that will be 84. So that's an 84 for 6 times 14. And then X squared here is 36. Now, down here, I'm going to record the sum of X, the sum of Y, the sum of XY, and the sum of X squared, because those were the constituent components of my formula for the least squares. So I'm just summing these different columns. So my first column, the sum of 1, 4, and 6 is 11. My second column, the sum of 6, 5, and 14 is 25. So I put a 25 there. My next column, the sum of 20, 84, and 6 is 110. And then the sum of my next column, 36, 16, and 1 is 53. Okay? So now I have all of the things I need in order to use the formulas which are up here. Okay. So now, if I want to find m, I'm ready to go. M is equal to, the numerator I start with n. N is the number of data points. So that's a 3. The sum of the product of xy is down here in the bottom in the third column. That's 110. I subtract from that the sum of the x coordinates, which I found was 11. That's the bottom first column. And then the sum of the y coordinates, which is 25. That's the bottom second column. In the denominator, I again use the n, which is 3, times the sum of x squared, which is the last columns, bottom row, or bottom entry, 53. And then I subtract the sum of x squared. This is 11 squared, because the sum of the x coordinates is 11. Now, of course, we'd probably want to break out a calculator, work this out. I handily have written down here that this is 55 divided by 38, which, let's just put this at about 1.45 for an estimate, right? I mean, the method of least squared is estimating based on data, and so data is always imperfect, so it's no reason that we need to keep a perfect answer. We can round the answer, and we should be safe. Any questions before I try to find B now? I'll pause for a second and see if anyone has anything they wanted to ask. Okay, now let's find B. B is equal to, the formula above says the sum of the y coordinates, which we found to be 25, minus m, which is 1.45 that we just found, times the sum of the x coordinates, which was 11, divided by n, which is 3, and this turns out to be around 3.03. So the line of best fit under the method of least squares is y is equal to 1.45x plus 3.03. That is the line that best fits that data. Questions? All right. Now let me talk about how to do this with electronics. One way is to use a graphing calculator. Now, there are some people who don't have a graphing calculator. Is this true? Yeah, okay. So what I'm planning to do probably for things which need a graphing calculator is I will allow you to use other technology like your phone, which might have a graphing calculator on it, or you can use other things on the phone in order to do that. So that probably means our tests are going to have two parts, one which is calculator free and one which has a calculator option. Okay. So, or no graphing calculator, just a scientific calculator. And then you can use a graphing calculator or your phone. But if you have a graphing calculator, it's good to get to know how to use these things. The details about how to do this, this is with the TI graphing calculators, are on page 29 of the textbook. And I'm going to write a short way of how this works in a moment. If you have a graphing calculator that's not a Texas Instrument graphing calculator, it can probably also do this. And if you want to know why, if you don't know how to do it, send me an email and I'll try to find a YouTube video that details how to do it. It might be hard for you to figure that out. I'd be happy to help you if you happen to have a different brand of calculator and want to figure that out. I can find a video that'll tell you how to do this. But this is how you do it with the graphing calculator. You enter the data as a list. There's lists for your calculators. There's like list 1, list 2, list 3, list 4, etc. Okay. And then there's in the Stat Calc menu, there's something called lin reg ax plus b. And then when you operate lin reg ax plus b, when you have a data list, it will come out, it will tell you what a is and what b is. It'll tell you the slope and the intercept. Okay? And then if you want to plot, you can get a visual of the data and the line of best fit with a stat plot. and graph. Okay, and like I said, page 29 of your textbook has the details on how to do this. Page 29 of your textbook also has the details of how to do it in Excel, if you care to do things like that. But of course, you probably don't want to have a huge Excel sheet or whatever when you're working on the exam. So graphing calculator is a good way to go. Obviously, at the end of class, if you want to come up and take a look at this picture or take a look at these steps, that's fine if you don't have your copy of the book yet. Okay, there's another way to do this, which is in Wolfram Alpha. And Wolfram Alpha is a nice calculator online because it's not as picky with how you enter things in. It can kind of parse natural language a little bit. And doing this with Wolfram Alpha is quite easy. You type linear fit, and then you put your data. And I'll show you how this works here. I would use the app, but the app only works in portraiture mode, not landscape mode. So this is going to be a linear fit, and it helps if you spell linear correct. And you can put it in 2 words, that's fine. And then you want to put your data. The data we just did was 1, 6, 4, 5, and 614. Okay, we put those 3 in and then we hit go. Okay, it gets something pretty similar to what we got, right? 1.4, 1.45 and 3.03. And it will automatically draw you the picture of the data points along with the line that you have. Okay. So like I said, I'm not going to require that you get a graphing calculator so that you can do these things on a test. On a test, there will be a portion of the test where you can use Wolfram Alpha in order to solve the problem. Any questions about these 2 methods? This is really slick, isn't it? You just throw in your data points, it's done. It tells you exactly what to do. Or it gives you even plots these things called the residuals. Who even knows what that is, right? You could think about it, maybe figure it out. All right. So now what I want to do is I want you to work on some in-class problems, of course. And then I'll assign the homework as well. So in class, please work on 4, 5, and 15. And then as homework, do Friday, so 6, 10, 14, 16, 20, and 22. And unless it specifies otherwise, like number 6, you'll see you have to fill in that table like we just did. But unless it specifies otherwise, you can use a calculator of some sort to provide the answer that you're looking for. Okay? So I'll leave the book open here for you to come take a picture, and I will come around and help you out if you are stuck and want some help on some of these problems. And then the quiz on Friday would be on perhaps 1.2, 1.3, and 1.4. Okay? So the homework ends. You'll need the second page for the homework. You'll need to turn the page to. And then if you want, where's the details on using your graphing calculator on page 29.